Good afternoon, dear colleagues. My name is Shakirgaliyeva Dana Gultimirbulatовна. I am an English teacher at Nazarbayev Intellectual School of Physics and Math in Almaty. Today you are going to see an online lesson in grade 12. The theme of the lesson is Language of Math and Science. This lesson focuses on content with language. It has a cross-curricular link with sciences as math, physics, chemistry and biology. To start the lesson, I would like to tell what kind of learning objectives we are covering. The learning objectives which are connected with content are: use speaking and listening skills to solve problems, creatively and cooperatively in groups, respect differing points of view, organize and present information clearly to others. The following objectives refer to language. They are: use formal and informal language registers in talk on a range of familiar and unfamiliar general and curricular topics. Ask and respond with appropriate syntax and vocabulary to open-ended high-order thinking questions on a range of familiar and unfamiliar general and curricular topics. Interact with peers to make hypotheses and evaluate alternative proposals on a range of familiar and unfamiliar general and curricular topics. Recognize the attitude or opinion of speakers in unsupported extended talk on a range of familiar and unfamiliar general and curricular topics. Let me introduce lesson objectives which are based on these learning objectives. They are: all learners will be able to discuss problems in order to solve them creatively and cooperatively in groups, ask and respond to the questions related to math and science. Most learners will be able to use language registers while speaking, understand each other's viewpoints. Some learners will be able to ask and answer open-ended higher-order thinking questions, explain their answers clearly to others. In this lesson, the students' speaking skills are assessed according to the learning objective 12S5, which is about interacting with peers to make hypotheses and evaluate alternative proposals on a range of familiar and unfamiliar general and curricular topics. Students can achieve this learning objective if they can develop ideas with their classmates in groups and can evaluate their classmates' suggestions as appropriate. As a hook, I show photos of famous scientists. In order students to guess today's lesson theme and to raise their interest to the topic, I ask them if they recognize the people in the pictures. Students are given about 2 minutes to activate their background knowledge and share their answer in small groups. When students call the name of the scientist, they are given the next question, which is: what do you know about them? At this stage of the lesson, I find it educational, to give the students some additional information about these people. First person is Alfred Nobel. Alfred Nobel was a Swedish chemist, engineer, innovator. Nobel invented dynamite and other explosives. He used his enormous fortune from 355 patents to institute the Nobel Prizes. The synthetic element nobelium was named after him. His name also survives in modern-day companies such as Dynamite Nobel and Akzo Nobel, which are descendants of mergers with companies Nobel himself established. The second person is Gregor Mendel. Gregor Mendel was an Austrian monk who discovered the basic principles of heredity through experiments in his garden. Mendel's observations became the foundation of modern genetics and the study of heredity, and he is widely considered a pioneer in the field of genetics. He was a botanist, teacher, and Augustinian prelate, the first to lay the mathematical foundation of the science of genetics in what came to be called Mendelism. The next person, it is Stephen Hawking. Stephen William Hawking is an English theoretical physicist, cosmologist, author and the director of research at the Center for Theoretical Cosmology. Hawking was the first to set forth a theory of cosmology explained by a union of general theory of relativity and quantum mechanics. He is known for his work regarding black holes and for authoring several popular science books. He suffers from amyotrophic lateral sclerosis. The last person is Alan Turing. Famous mathematician Alan Turing proved in his 1936 paper on computable numbers that a universal algorithmic method of determining truth and math cannot exist. Alan Turing was a prominent and influential mathematician, cryptanalyst, logician, and a computer designer and a scientist. He helped pave the way in the field of computer science. Thanks to his Turing machine, he called it an automatic machine, a hypothetical device created in 1936 and representing a computing machine which helped make formal concepts such as mechanical computation and algorithm. To lead students to come up with the idea that the lesson is about that the lesson about science, I put them as two questions, which sounds like this: what do they have in common? What aspect of life are they connected with? The students' answers might be: these people are famous, they are scientists, they are European, and at the end I have an expected word science. To get the word math for students, I ask them two more questions. What is the door and the key to the sciences? And second question, what is the queen of all sciences? Asking these two questions one by one, I give students an opportunity to practice their analyzing and critically thinking skills. This approach is crucial for generation of the 21st century, who is supposed to have critical thinking skills to solve different problems in life. The other aim to this task is to raise students' awareness of the importance of math in other sciences. Students are supposed to come up with the idea that math is the door and the key to the sciences. It is mathematics to be the queen of all sciences. So the students have the theme of the lesson. The theme of the lesson is language of math and science. When they have the theme of the lesson, I set students into pairs and ask them to discuss this quotation by an English philosopher, Roger Bacon. Mathematics is the door and the key to the sciences. I give them about 2 minutes for discussion, and as a feedback on the task, I ask some students to share their opinions with the whole class. I show the students a picture of an owl and ask them what famous game show is associated with it. They answer what, where, when. After that, we move to the main part of the lesson. I tell them that they will play an intellectual game, what, where, when, which can help them revise their knowledge of math, physics, chemistry, and biology for this term of the academic year. To play this game, I divide my class into 2 teams of 5. Each team can be named up to their own choice. The first team chooses the question to be opened. When question appears on the board, teams need to discuss quickly in the group and try to find correct answer in short time. The team that gives the sign of their readiness, for example, students clap their hands and they start to answer the first. If their answer is wrong, turn to answer moves to the next team automatically. After the question is answered, the second team takes the turn to choose the number of a question and the scenario repeats. 1 point is given to a team who has the correct answer. The team scoring more points is declared a winner of the game. When students choose a number, the question appears. For example, the first question number 1 is related to physics. I ask this question: If you have 3 radioactive cookies, alpha, beta and gamma, what will you eat? Place it in your pocket and hold it by your hand. After giving 1 minute for discussing, I'll show the correct answer and students compare their own answer. The correct answer is: you eat the gamma cookie, put the beta cookie in your pocket and hold the alpha cookie in your hand. Here's why. Your skin will stop the alpha radiation, so it's safe to hold that cookie in your hand. Your clothes will stop the beta, so it's safe to put that in your pocket. And if you are going to have to eat one, you may as well eat the gamma cookie, because gamma radiation is so penetrating that you get the same does whether you hold it in your hand, put it in your pocket or eat it. The next question is related to mass. Evaluate e to the power of I pi. I'll give you 1 minute to students to discuss in their group. Let's look at correct answer. Correct answer is parenthesis cosine pi plus I sine pi, parenthesis -1 plus I times 0 equals to -1. The third question. Question number 3 is related to biology. Antibiotics are generally effective against bacterial infections, but cannot be used to treat viral infections. Explain. It's an open question and the students give their own answers. So, the next question. The next question is related to chemistry. Question number 4. What is the test for unsaturated hydrocarbons? And let's look at correct answer. Correct answer is: add bromine water to unsaturated hydrocarbons. Color of bromine changes from red-brown to colorless. The next question, it is question number 5. Question number 5, it is black box. As a rule, it is supposed to be something in the black box. So, I read the students a riddle about this hidden object, so that they could take a guess what is inside the box. And it is riddle: what lives on its own substance and dies when it devours itself? After 1 minute discussing, I'll show the correct answer. Correct answer is a candle. the next question. Question number 6. Question number 6 is related to chemistry. Why are transition metals colored? And correct answer is because they have empty d orbitals and electrons light causing the color. Question number 7. Question number 7 is related to math. Question: name at least 4 properties of the function y equal arcsine x. Let's look at correct answer. Correct answer is first step, domain dx equals 2 minus 1 to 1 exclusive. Second, range e of y equals to minus pi half to pi half. The third, increasing. Fourth, odd function arcsine minus x equal minus arcsine x. And the fifth, symmetric in the origin O 0, 0. The question number 8, it is physics question. What effect discovered by Faraday is the working principle of an electrical generator? The correct answer is electromagnetic induction. The next question, it is question number 9. Question number 9 is related to biology. Describe 2 different uses for DNA fingerprinting. As you see, it is an open question and I expect to have students' own answer. Question number 10 is in this game is video question. Let's watch this video.
Okay, hello everybody. Here is one question in probability I'm going to give you. So, Jane plays a game where she tosses 2 fair 6-sided dice. She wins a prize if the sum of her scores is 5. Question: Jane tosses the 2 dice once. Find the probability that she wins a prize. Second question: Jane tosses the 2 dice 8 times. Find the probability that she wins 3 prizes.
Okay, now we are going to watch how the students discuss and find the answer to this question, and also compare their own answer with the correct answer.
6-sided dice. She wins a prize if the sum of her scores is 5. Question: Jane tosses the 2 dice once. Find the probability that she wins a prize.
Probability question, we can do it by just using the formula, right?
Yes.
It's like 6 sides.
6 sides.
And
It's
she
probability. She will 5.
If the sum of the scores is 5.
Yes.
One of them will be 2 and 3. And 1
And 4. 4 and 1.
4 and 1.
1 4.
And
4 1. 4 1. 3 2. 3 2. No. There is no 0.
And first time. 1 over 6.
That's it? Are you sure? So what counts 4 and 1, like a controversy? But I guess, why? I think the main,
Yeah, like that. I think that we should, well, if we think that oral 21 combination, we should use only this one.
okay, let's count only this one, because we need only sum.
Okay.
The sum should be like 5, yes?
2 over 21, it is
Getting exactly.
To win, we should get 1, you should get 5.
and 4, 6, 1 over 6 is...
Yes,
4 choices.
It says 1 over 6 is... Wait,
36
6
will be
multiplied by
4.
It means 1 over 9.
9, yes.
and the answer is 1
We
over
don't
second-
have side
second-
0, that's why we cannot choose the
5 and
this 5 and 0 chance.
And that's why 4 choices.
Yes.
Okay, the second question.
Second question.
2 dice and 8 throws this 8 times and find the probability.
When
We should
exactly
win 3 times. We should
times.
win 3 times. It means that
No, to win in one time, to win, we have to get
1 minus
1 over 9.
So we're going to present our answers that we made by our old group mates. So this was the probability questions. Then we thought that it will be kind of solved by the specific problem, and then the given task is like that. The first question tells that there are 2 fields of 6 sides, and the person who throws this will win if the sum of the scores will be 5. And we should find out the probability here if he throws or she throws the 2 dice. And then as the sum of the all choices is 5, we make the 4 choices because 1 plus 4, 2 plus 3, and the against of this, so there will be still 4 choices. And then we calculate it like that.
Okay, and as we know, one of dices should get 2 and one of dices should get 3. And the probability of getting 2 is 1 over 6, because dice have 6 sides. And the probability of getting 3 is similar, 1 over 6. And because we have 4 chances to win, we have to calculate this all.
The task is the Jim rolls the dice and he wins if he gets in sum like 5. And the ways of getting 5 is 1 plus 4, 2 plus 3. And we didn't count 4 plus 1 and 3 plus 2 because we think it doesn't matter the sum of 2 dices, like 5 matters. So we got first answer for the first, it's like 2 divided by 21. 21 because it's the 21 ways of getting any number. Like starting with 2, it's like 1, 1. And ending with 12, it's like 6 plus 6. And the answer for the second is like, to solve this, we we multiplied 21 over 2 over 21 3 times because it's probability of like getting 5, only 5, and getting 5 it means winning. So winning it's like 2 over 21 3 times, and the probability of losing is like 19 over 21. And it's like 5 times. After 5 throws, he like loses. And we multiplied all this, and we got like 52 divided by 10,000.
Now guys, let's check your answers.
Here are the answers to the questions. So answer to the first question is 1 over 9. You use just the basic definition of probability. The answer to your second question is 0.0426. You use binomial probability. Thank you for your attention.
Okay. Now, while the students discussing the question, I am going around and monitoring the students according to this success criteria. 12S5, interact with peers to make hypotheses and evaluate alternative proposals on a range of familiar and unfamiliar general and curricular topics. And the game is over. The result of this game is that students can show their knowledge in different subjects as well as challenge to find answers to unknown questions. Thus, they develop speaking skills by solving problems creatively and cooperatively in groups. As a homework, students will be given a task to create a range of questions for their own games. To have feedback from my students, I ask them to complete this card. About, they should tell 3 things: what they have learned today, what they have done well, and what would like to find out more about. I appreciate my colleagues for their help in providing me questions in math, chemistry, biology, and physics. Thank you for your attention.